Hello and welcome to the SWIB Podcast, where members of the Wisconsin retirement system can turn for timely information on the investments that help fund the state's pension system. I'm Chris Preisler, Communications Specialist for the State of Wisconsin Investment Board, or SWIB. Public pension systems have always balanced two big priorities: delivering secure retirements to members and safeguarding assets for the long term. Now, artificial intelligence, or AI, is entering the picture. Some funds are already experimenting with generative AI to sift through mountains of unstructured data in seconds. Others are deploying chatbots to handle routine questions, and many are grappling with governance, ethics, and transparency in these powerful new tools.
In this episode of the SWIB Podcast, we'll talk to Cefe Quesada, SWIB's Chief Technology Officer, and Salah Khalaf, Senior Portfolio Manager, about what's working, what's next, and how public pension funds can embrace AI while keeping transparency and performance front and center and helping the WRS remain fully funded and well-positioned to deliver on its promise to over 692,000 participants.
The SWIB Podcast is a regular opportunity for you to learn more about the people and funds that comprise the Wisconsin retirement system. Please make sure to subscribe in your favorite podcast app so you don't miss an episode. Share this podcast with your fellow WRS members and leave a review on Apple Podcasts so it's easier for other members to find this show.
Today, we welcome to the SWIB Podcast Cefe Quesada, SWIB's Chief Technology Officer. Cefe joined SWIB in 2024, and as Chief Technology Officer, he's responsible for the entire SWIB technology and data architecture. This includes responsibility for developing and leading the organization's technology and data strategy, overseeing the implementation and maintenance of solutions that support SWIB's goals and objectives, and driving technological innovation to keep SWIB at the forefront of the changing investment landscape. Cefe earned his bachelor's degree from Pacific Lutheran University and his master's in Applied Information Management from the University of Oregon. And joining us also is Senior Portfolio Manager Salah Khalaf. A leader in data analytics at SWIB, Salah's work in developing advanced quantitative tools has been transformative in bringing robust data insights to the investment team in assessing portfolios, managers, and funds. Salah joined SWIB in 2022, earned his bachelor's degree from the University of Wisconsin-Madison and his master's degree in financial mathematics from the University of Chicago. So Cefe and Salah, thank you both for joining us on the SWIB Podcast.
Thank you, Dusty.
Yeah, great to be here. Thanks.
So I'm sure that our audience is familiar with the term artificial intelligence. It has come up a few times over the past years in news coverage, in trade publications. It's kind of everywhere. But everyone may not understand is exactly what AI is. A lot of us have used Alexa or Siri to answer questions, and those are sort of like AI adjacent. But those are really just the tip of the iceberg when we're talking about this new technology that's really been making waves over the past few years here. How do you explain AI to someone without any technical background?
That's great. I'll jump in here, Dusty. That's a loaded, difficult question. I'll attempt to answer. So I think in the kind of modern context, when we talk about artificial intelligence, AI, what comes to mind is kind of ChatGPT and OpenAI. And that really kind of burst onto the scene in 2022 when OpenAI released ChatGPT. And I actually was working at Morgan Stanley at the time. I had heard about it. I logged in, was one of the early kind of adopters. So you get an account. And it was like magic, right? I remember just being kind of blown away at the way that this artificially intelligent tool was able to interact with me. I was going to say like a human person, but really above and beyond a human person, almost like a superhuman person. And we really look in retrospect back at that time in 2022, it's kind of a tipping point, right? Where AI really kind of came into the national conversation. It was, the water cooler topic for sure across all industries. Now, in the context of kind of answering the question, kind of what is AI? AI as a discipline had been around for a number of years in kind of computer science circles, right? So, these concepts of like machine learning, computer vision, natural language processing, right? This idea that computers could understand kind of human conversation and thought. That had all been around for a long time. And that was essentially kind of our general populist understanding of what artificial intelligence was limited to those areas. But, soon after this concept of deep learning came along, if you could put, these large language models of artificial intelligence into a box, it would kind of fit into that deep learning category of these kind of artificial neural networks that are trained on essentially kind of all of human history language, right? That create these models that can act as if they comprehend context of human language, but also generate response in human language. And so when we talk about that, the answer to that question, what is artificial intelligence? Technically, it is this field of deep learning, right? Where computer scientists have created these large language models that have developed these neural networks, right? That are able to approximate human understanding and also generate language. So that's about as less technical as I think I can get, Dusty, without muddling the waters.
I've heard some really good descriptions of it where it essentially asks you to think about how you learned how to speak and you learned how to think, right?
Yeah.
And you were exposed on a daily basis to other people's language. You came to experience the world as a kid. Gradually, you started to learn what words are, and then you started pasting those words together into sentences. And then you started to apply your understanding of those words to the things that were happening around you. Essentially, what large language models do is it tries to create an inorganic version of that learning process. But because an inorganic computer is not an organic human brain, it essentially takes billions and trillions of processing steps, and you just throw a lot of data on it, and eventually it starts to sort that data out. You just need a really big, powerful computer. Is that oversimplifying? Or is that overcomplicating?
No, I think it's a really good metaphor, right? I mean, the technical phrase that's used in computer science circles is a neural network. And kind of how you described it, kind of a child's brain developing over time, concepts, ideas being reinforced, right? Those are all kind of concepts and terms that when we talk about large language models, right, we talk about reinforcement learning, we talk about the number of neurons called parameters in the context of large language models that are present in the new frontier models. So I think it's actually a perfectly apt metaphor for how you could think about the brain development in an organic sense and how we think about this artificial kind of neural network with reinforcement over time because it's trained on billions, trillions of words and data sets. And then post-processing, they go through fine-tuning and even more reinforcement learning, right? Create an experience that is more akin to what you'd expect kind of a human neural network, so to speak, to interact with and respond. I think it's a perfectly apt metaphor. It's again, that language is used in both those disciplines.
I had the opportunity a few years back when I was working on a project designed to get heavy equipment manufacturers in North America to start preparing for the advent of AI. To actually go out to a laboratory in Silicon Valley. This is 2017, 2018, when the technology was still formative. But they had built one of these neural networks to be used in a computer-assisted design process, essentially, where you feed it specifications. The example that they showed us was, we need to design a swing arm support strut for a motorcycle. It has to fit within this volume and it has to be able to resist this much torsion on it. And then essentially what the computer did was it really quick iterated about 1 billion different designs, and about 999 million of them were completely unusable. But the analogy that they used was, it's like 1 billion monkeys working at 1 billion CAD stations. A few of them are going to come up with usable designs. And I thought that was just a really, really neat way to see the technology employed at that time. It's come a long way since then.
Yeah, and I'm guessing if you took that same example that you just ran through, Dusty, from 7 or 8 years ago now, that output, the result today is probably significantly faster to get to that point as well. And that's how far along we've come in this short window of time.
Yeah, essentially the big difference in technology is that the computing power is just a lot greater than it was back then. The processors are more powerful and there's more of them to enable these LLMs to develop that much more quickly.
Yeah, what's fascinating is obviously the amount of compute and power and time is significant. And with every kind of new frontier model, it takes more time, more GPU, more compute. But what's interesting is just from a perspective of being able to leverage these tools, the output is quite small. So you have this model that was trained probably for months on, at that point, probably billions of tokens of words and data. But the output, you could run on your laptop, right? which is still the case. And so it is quite fascinating to see the maturation, the cycle time of improvement is so fast. Google, talks a lot about this, right? That even their AI engineers, as they think about building solutions, they talk a lot about trying to build towards where it's going, right? Because the minute they deploy a new solution based on the model, everything changes. So it's an exciting time right now, but also a challenging time for solutioning. And we'll get into this too, because Salah's been at the forefront with a lot of this stuff within his organization. It's challenging, right? Because you can come up with really interesting, neat solutions. And then, a month later, this slew of new tools and features gets developed and you feel like you have to start over from square one.
So it's something that's progressing or changing. But I think the perception out there with a lot of people is that AI is this new tool and it's perfect, like plug and play, right? So what are some of the misconceptions people might have about AI? And then what are some of the concerns with AI and how it's growing or progressing or how people are using it?
Chris, I love this question because I truly believe the misconceptions is one of the biggest problems that we have with AI. And I think you touched on the first part, which is a lot of people think that AI is the solution to everything. And my biggest fear is that, especially with your latest and your newest graduates and people who are coming through the universities right now, and students in general are becoming more reliant on AI. And what's happening and what you're seeing is that people type in a question into, let's just use ChatGPT as an example. They type in a question, they get the solution, they maybe run the output, and they think it's correct. But without the formal training and understanding of the nuts and bolts, what you no longer have is the ability to tell you whether the solution is actually correct or wrong. And is it going to actually work in a production environment? Let's say you're coding up a solution, you get code and you throw it into a production environment. Well, what if it starts to hallucinate and start to make its own results? And then now you're in a loop and you've broken the system. And this is something that a company relies on, or, it's a source code or an issue from that perspective. So I think that's one of the misconceptions is it's going to solve it for you. And then the other component that I really want to touch on, and this is an example that I like to use quite a bit, the difference between what you used to do and what you do today with ChatGPT is, if you think of Google for an example, and you would just Google something, when you Googled and you were trying to search for an answer, you would receive multiple outputs, pages. So thousands, we're talking about thousands of results, right? And you'd siphon through it to figure out which one was the actual item that you were trying to get to. ChatGPT or AI in general, that's different. You enter the question, you get basically one result. And you think because it's AI that it's the affirmative, it is the correct answer. And I think people really need to start thinking of it as a tool. And one example that I will give, and then I'll love to get Cefe, your take on this as well, is if you use AI, however, so moving away from the misconception, if you use AI for what it really is designed for, if you have the nuts and bolts and you have the underlying concepts and you know what you're trying to get to, what AI can really do and where it really benefits someone is it could take somebody from being a master of a subject to getting to solutions that much quicker. So like if you think about your engineer who's like a 10x coder, this might make them 100 times better coder, right? Because they're getting to solutions a lot faster and they're finding those little minuscule details. And that to me is where AI starts to move from a misconception to a powerful use source.
No, that's great. I mean, maybe just to build off of that, I've heard a lot of forward-thinking engineers in the space, talk a lot about how if you have a poor engineer at the keyboard, it's not going to turn them into the next Bill Gates or Steve Wozniak or whoever, right? But it will make an exceptional critical thinking engineer that much more effective, that much more efficient, that much more better at their job. Back to your original question though, Chris, around kind of what are some of the misconceptions? So I think the first one, as I thought about this question that I jotted down was, it's this thinking machine, right? And, I go back to the first time I used it, it did feel like a magic trick that you were kind of typing words into a box and this magic box was responding kind of in kind with all of the world's knowledge, right? But the reality is they don't think. They are, as we kind of started the conversation, just essentially responding based on these statistical relationships that have been trained on, with the first model, billions of parameters. And now I think Llama 3, and I don't think OpenAI has confirmed this, but I think also the latest versions of ChatGPT are trained on trillions of words, right? So these are massive, massive, massive data sets, right? And so they don't think, right? But they leverage this neural network and function that has been developed by training for months on these trillions of words and concepts as they go through their training runs. The other bit maybe that I would say there as far as misconception goes as well, I feel like my previous answer might have led people listening to believe that we actually know how these things work. And, we certainly know how the math works, right? We know how the modeling and statistical outputs function at a kind of a practical, I guess, engineering level. But, when you talk to AI scientists in the space, the reason that they're working 120 hours a week and not taking vacations and they're getting paid all this money is a lot of this right now is experimentation, right? This is kind of like, they call them frontier models. I don't know if this is on purpose, but part of the kind of frontier from my perspective is it is a new frontier. They literally don't know what these models can do. And so they will run experiments, right? It is very much an act of discovery right now with these tools.
Well, again, Cefe, you mentioned that these models have been trained on now trillions of perhaps iterations, simulations that are run inside of a computer. And it's not like the coders who are building these things can go back through and check the work on these trillions of simulations. There's not enough coders and hours in the day for that to happen. And so in a lot of ways, these things are a black box where we put them in motion and then we kind of stand back and watch what happens.
Yeah, I think we're getting better at it, for certain. And I think one of the things that we've worked hard on at SWIB is trying to understand kind of that point, right? How do I check the output? And I will say there are increasingly really interesting tools that'll actually allow you to compare AI output to a known kind of corpus of known correct to good answers, right? And that software space kind of giving you an ability kind of check output is evolving. It's getting more mature. In the future, you're going to have a higher level of conviction because you're going to be able to test that accuracy before you go into like a true kind of production environment.
Just to circle back to one of the points that was being made on the training and the data side is just, for people to keep in mind, and this is probably one of those like misconceptions as well, in terms of this is all historical data. This is based off of stuff that we've already witnessed and the models have seen. So that's what you're training it on, right? It's building solutions off of data that we already know happened and data points that happened. So it's not going to give you something that is technically net new. You could ask it to generate a design or a video for you today and some other items, or, you have a solution in mind, but it's using something that was already built. And that's one thing that people need to realize, that as new things get developed and new things are created or new items happen, that's why the training continues to happen and AI continues to evolve and get better. And then the second item that I was going to touch on, and Cefe highlighted this point of what we've learned when we're doing things on validating the data in the black box and understanding those data points. One thing that I think is extremely important to really highlight, and this is based off of the experiences that we had, the human in the loop is of extreme importance, especially at this stage. You can't just deploy AI and rip the Band-Aid and say, hey, we're going to trust everything it gives us and we're going to use it. In my role, we're building a lot of analytics and quantitative tools and data sets, which relies heavily on the first input, which is having the cleanest level of data. And so if those data points are not validated and ensured that they're actually being extracted correctly and then inputted into the systems for calculation purposes, now it's garbage in, garbage out.
So that was going to be one of my points, or one of my follow-up question, I guess, was AI is only as good as the humans behind it. Is one of the bigger misconceptions that you can just plug in this AI tool, it's going to replace humans. You can get away without the human behind it.
So what we were talking about now, what we've been talking about is some of the limitations, right, with these AI tools. They are significant, right? I think, when Salah and I and our team started really kind of getting into some of the weeds with this stuff, we were very impressed early on. And then, at the edges, it was very apparent like, ooh, okay, yeah, we have some work to do here to actually get this thing, in a position where it could be production ready. The reason we get excited about these tools is that they do demonstrate a capability, and in Salah's case, in the domain that he cares about, certainly display a command of the domain. What is challenging, however, is when you're starting to feed your information in that isn't generally available information, that's where you start to see some fraying around the edges. And from our perspective, like, you continue to have some humans in the loop. This is a SWIB podcast, so I will say, by policy, any medium risk solution from an investment decision or a research standpoint, by policy, right, you have to have a human in the loop still, right? And I think we're a ways away from ever moving away from that policy right now.
So what about some of the concerns that come with the use of AI?
So, there's a lot of general concerns, and a lot of these particular concerns that I'll list out are ones that we certainly had to work really closely with Salah, and Salah has probably lots of battle scars and firsthand experience stories on how you deal with some of these concerns. But, number one for SWIB in particular was the concept of hallucinations, right? This idea that AI would not just respond incorrectly, but so far beyond the pale to almost render it kind of useless.
What we learned from a hallucination perspective is different documents come with different issues. So if a table is structured in a different way, if the AI thinks the tables are all the same, it starts to actually give you the wrong reading because it can't actually decipher the two tables that are different. One, it could be structured in a very unique way that it can't traverse it or it can't extract the data point correctly, but it thinks it's doing it correct and it gives you the answer. And the answer is actually for the wrong either period or a different fund, etc. And so you really have to be able to look at the citations and assess it and make sure it's not hallucinating. You have to make sure that you're looking at the right pieces, especially when you're doing these first level round of testing. Trust but verify, I guess.
SWIB is not the only organization right now that's trying to integrate these tools. Kind of seems like AI is being rolled out throughout the business world. And in fact, AI spending, I'm told, is approaching 2% of GDP. So my question is that sustainable?
So I'll give this a go, and then I'm going to be interested to hear from the guy who actually sits in the investment management side of the house. So, this is pure punditry, I guess, in my answer here. I'm not an economist. I'm not an asset allocator. But, just from a pure technical perspective, some of the things that I see that, definitely, raise an eyebrow is just a sheer kind of volume and spending that we're seeing on AI up until this point. Over the last 6 months, you've seen OpenAI in particular announce partnership deals with everyone from NVIDIA to Broadcom. They just announced one last week with AWS. Prior to the AWS announcement, I want to say that investment over the next number of years was about $900 billion. So that's a massive amount of investment in the space, up and against revenue for OpenAI, which I think this year will be about $12 billion. So to keep the metaphor going of a toddler, right? My simple kind of toddler math really starts to kind of question, well, that's $1 trillion up against, $12 billion in revenue. That doesn't make a ton of sense. And when you actually look at the expenditure, depending on who you ask, 40 to 60% of data center build expenditure are just GPUs. And GPUs have a shelf life of 3 years, maybe. And so, it is a big infrastructure investment, but half of that infrastructure investment has a very short shelf life.
This is a very hot topic. I think everybody is trying to really assess that. And not to use the term, but I think everybody's trying to ask, are we in an AI bubble? And so is the spend sustainable? Can everything that we're seeing, the investment side of it, the number of warehouses that are being built to house those GPUs, the level of investment that's taking place, can it continue and can it go at that pace? One thing that I won't do is try to pinpoint when a bubble will take place or when it will pop. And I think that's a very difficult thing to say. If you think back to like the internet age, there was a lot of spend that was taking on during the tech bubble. And so what happened there is that you had a lot of spend. And then after that happened, we got into a bubble, the bubble popped. But don't forget the number of investment that took place at that point in time really set up the stage for the next round of growth that we've seen. So the likes of Amazon that benefited off of the backs of that initial investment and being able to take advantage of it. If you think about like the whole fiber optic stage, right? There were companies that were laying so much fiber across the US and they got over their skis and that went out. But look at what we have today in terms of all the cellular networks that we have and the internet capabilities. And I think that's what a lot of people are trying to unpack today. Who are going to be the long-term winners.
Who's going to be the Amazon and who's going to be the pets.com?
There you go. Exactly. That's exactly right. Or, MySpace and Facebook, right? Facebook, Meta, I got to use the right terminology. But yeah, that's exactly what we're weighing out.
Well, it's certainly a fascinating time to be in this space. And you've alluded a few times during this conversation to some of the AI tools that you are developing for use at SWIB. That's such a fascinating and deep topic that we've actually decided to cordon that off and address that in a second episode. So this is going to be our first 2-part episode of the SWIB podcast. But at this point, I'm going to thank you both, Cefe Quesada, SWIB's Chief Technology Officer, and Senior Portfolio Manager, Salah Khalaf. Thank you both for joining us on this episode, and we'll look forward to part 2 of this conversation coming up in a few weeks here.
Great. Thanks, Dusty. Thanks, Chris.
Thank you, Dusty and Chris.
And thank you to all our listeners for checking out this episode of the SWIB Podcast.
The SWIB Podcast is brought to you by the State of Wisconsin Investment Board and produced by PodCamp Media. Branded podcast production for businesses, podcampmedia.com. Our editor and board operator on this episode was Harrison Fonder.
Thanks again for listening. I'm Chris Preisler.
And I'm Dusty Weiss.